Okay, you have a piece of line here called this fx. Okay, you're trying to find the area under this curve using a trapezoidal rule. Let's say I'm trying to approximate the area under this curve. First, I want to approximate a straight line, a polynomial of degree 1. This is a polynomial. Assume this is a polynomial of degree 1, px. Is the actual fx is the actual curve. Just drop a line from there and call this A, call this endpoint A. X value A, then this will be your X value B. So your x-axis, x-axis, and then you can call this y-axis or fx axis. Corresponding to the A value, you're going to get a FA value. Just like, you know, when there's a, for every X value, there's a Y value. Similarly, for B, when X equals to B, you get a corresponding Y value or FX value. So we can call this endpoint A, FA. On this, the other side, you can call this B, FB. Okay. So now what we want to do, we want to interpolate from the previous lesson. We know what is interpolate, right? Interpolate means you try to approximate a polynomial with another function. You try to approximate, you try to develop an equation to approximate the polynomial. Interpolate fx with a polynomial of degree 1. Polynomial of degree 1. Like for example, polynomial of degree 2 will be like, you know, for example, this y is equals to x squared. So in this case, we are trying to do px equals to x squared. This is a degree 2. So we want to get a polynomial of degree 1. Okay, there can be another constant here, we don't know, C or something. So something like this, a polynomial of degree 1. Polynomial of degree 1 is a straight line. Now let's go ahead and write an equation for the straight line. This straight line here. Go ahead and write an equation for this straight line. Okay, if you guys have a pen and pencil and paper, maybe you should try to write this. So I'm calling this Px, and then you are given all these endpoints. Delete all these things. Px, B, FB. So you know the endpoints. You know this is like, for example, for now you can assume that the axis, like this is x, and this is Px. Px. Just like saying Yx. You know, remember how you wrote an equation of a straight line for Yx. If this is x1, let me put this in a different color. How did you write the equation of a straight line during your college algebra class? Remember you have had xy axis. How do you write an equation for a straight line? You go like y minus y1. You can be anything. You can either be y minus y1 or y minus y2, but you have to be consistent. Y minus y1. If you decide to choose this endpoint, then it's going to be y minus y1, and the slope multiplied by x minus x1. Okay. You guys recall this? Are you all still connected?
Yes, sir.
Yes, sir.
Okay. So using this, what we know from the past, so we can write an equation for this line. So go ahead and write Px minus, let's say if I'm choosing the left-hand point, I'm choosing this point to write an equation. I'm using this set of points to write the equation. So Px is going to be Px minus Fa is equals to slope. What is the slope of this line? So slope of the line is FB minus FA divided by, you remember what is the slope of a straight line in your college algebra? You go y minus y1 divided by x2 minus x1. Or it can be the other way around. But you have to be consistent on the numerator and the denominator. Okay, that's slope of the line. Then multiply by what? Multiply by looks like no answer coming, so let me do it.
Px.
Huh?
X minus
X
A.
minus A, sir.
X minus A. Thank you. So if you guys understand in the class, then it will be very easy to study for this class. And naturally, you're going to do very well in the exam, assignment. So once we find this equation, so Px is going to be so this is the equation of the line we're talking about. So once we have the equation of the line, so this is the equation of the straight line, a polynomial of degree 1. So now to find the area under this curve, you want to find the area. Let me bring this down here. You want to find the area. This area. We call this area, maybe call it I as a function of f. So this area can be found. So this is the equation of the line. Equation of the line. We found the equation of the line. So to be able to find the area under the curve, maybe I should so this is fx, and this is the red one is px. So if you want to find the area under px, which is like approximating the area under the actual curve. So you can approximate the area under the actual curve using i's of f. I as a function of f. I as a function of f is the area under the linear polynomial of degree 1. The actual area, so this is the actual area. So the actual area can be predicted can be predicted using the equation of the straight line that we developed. Maybe guys, it's too small. I think let me bring it down here and magnify it. Okay, you are trying to approximate the actual area using the equation of the line that we developed. Is it okay so far?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, good. The rest is, to integrating this. Let's go ahead and integrate this. Before integrating, what we want to do, we want to write all the integrals in individual. We want to separate the integrals. For example, you have one term here, you have another term here, a separate term here. So you want to do 3 integrals. The reason for doing that, you'll see when you do them separately, you'll be able to simplify this into a compact form of equation or trapezoidal rule. The first integral is fb minus fa divided by b minus a x, okay, dx. The second integral is minus a, because there's an a there, so you put minus a dx, a to b. Agree?
Yes, sir.
Thank you. Any objection?
No, sir.
No, sir.
So the last integral is the last term with three terms, 1, 2, 3. fa dx. So you go ahead and integrate this. I don't know if I should assign this as an assignment or should I do it? Okay, let's do it. If you know how to integrate, integration is not a big deal. Then you have to put them in, simplify them. That's kind of a little bit challenging. So if you integrate them, what you get is FB.
Sir,
Yes. Yeah.
for the middle part, should be A multiply F bracket B minus F bracket A divided by B minus A. Am I right?
Yeah.
Like
Yes. Yeah.
Like the first form. Am I right?
Yes. Yeah. Sorry about that. So like, because you have this term, so you have this term multiplied, you have this term, you have this term multiplied to this, and then this. So you have to also have the other term here. You can either put it outside or inside, it doesn't matter, you know, because this term is a constant. You can just leave it outside here. FB minus FA. So I was going to say was like, this is a constant. This is also a constant. A is also a constant. You can actually leave all of them outside. Okay, then constant. Then you have this, the last one here. So I'm writing this really big so you can see this easily, especially if you're using your little phone to see it. But I recommend you sit in front of your laptop, open it, you write properly, take notes. You know, you don't jump out of the bed at 8 o'clock, you know, lying down and looking at it. It's not going to work. You just treat this like a real classroom. Take your laptop out, a notepad, pen. Have a good shower or something before that. Dress up as though you're in a class and sit and do it. This is also a constant. I myself, I haven't had my shower, but you know, but I had my cup of coffee. I'm also not dressed up anyways. I don't practice what I preach. But I think students should do that. Okay. So if you want to save yourself some confusion, you just leave the constant outside the integral sign. Thank you very much, Jay, for pointing out that mistake, because without that, you'll end up getting a wrong answer. So you put it outside here, and then you put the constant inside. So I'm going this quite slow here because in a way that you can also brush up your integral. Then you have an A here. You have an A. Then what you have inside here is just 1 dx. First, have to put the integrals right, put them correctly in correct position. Then you integrate. You'll be less prone to be making mistakes. Oh my. Integral of x is x squared over 2. A to B. Minus FB minus FA divided by B minus A. A The integral of 1 dx is just x, right? Lower limit a, upper limit b. Then plus the integral, again, you have just 1 here. For example, here, just dx or just 1. They are both the same thing. You can just leave it as dx. You don't have to put 1. So the integral of dx is x. Now you just go ahead and plug in those limits. Upper limit minus lower limit divided by 2. Then you have FB minus FA divided by B minus A. There's an A here, don't forget. But then you upper limit minus lower limit. Plus FA multiplied by upper limit minus lower limit. Now the rest is you have to simplify it and put in a proper form. If you don't do that, then it's going to be very difficult to use this formula to do the numerical integration. Okay, now what we're going to do on the side, FB minus FA and then you have B squared, 1/2 can come outside. Then you have B minus A into, actually all of them can come outside, B minus A, B plus A. Okay, for the first term. The second term. And next, what we're going to do, we're going to try to combine the B minus A. So the common factor here is B minus A, B minus A. We're going to factor that out. Factor the B minus A. Okay, let me do this on the second line because I don't want this to be too small. Okay, David here. Factor out the B minus A. Plus you factor out the B minus A. So what are you going to have inside here? You're going to have FA minus FB minus FA divided by B minus A multiplied by A. This part here is this part. Any question on that? Any mistakes or?
No, sir.
All right. Okay, thank you. So now these two can cancel. This here and this here can cancel. Correct? Now what I'm going to do, I'm going to multiply this through. I'm going to multiply one by one. Just now I factor out, I'm multiplying this again. Okay. Multiply them out. Then you're going to get FA, B minus A into minus A the next logical thing to do, I think, we just multiply them through, each one of them like this. So it's going to be B, FA minus A, FA minus B, then minus B minus A, FB minus A or plus A, FA. So these two can cancel, I think. We are not done yet. Still, we have to make them more compact. Then go ahead and multiply this term also. Maybe I should have done that earlier, but never mind. I was just doing step by step. Maybe I forgot to do that. Now you just multiply these things one by one. See what you get. So you leave so of course, there's some serious algebra work being done here. So you have to make sure that you have to do them without making much mistakes. So FB A plus B, FB minus A plus B, or B plus A, or whatever, A plus B minus FA plus FB, FA AFB plus B FB minus AFA minus B Are you guys following? Am I doing this right?
Yes, sir.
This can be found in my Google Notes, but the Google Notes is not complete. It shows you some partial steps, but didn't show the full steps. But if you look at that, it will give you a pretty good idea what to do next. Okay? So don't remember Friday, do on Friday. Do on Friday. What's the date on Friday? Friday 17.
17, sir.
17-4 or 5-4, right? Okay, now we will see how to apply this formula to solve a problem. Okay. Example. You're given a function Okay, I'm going to, if you don't mind, I'm going to pull out this drawing from my previous lecture. You're going to have some error here. Definitely you're going to get some error in this area. There's some error here. They're not going to be accurate. But anyways, you're going to approximate the area under the curve using the trapezoid. How many trapezoids are here? There are 1, 2, 3, 4, and 5. Okay. So we split that area. So you're trying to integrate from 1 to 6. So the length of each trapezoid, the length, what I mean by the length is the length from here to here. So the length from here to here, each one of them is like delta x. So from here to here also is delta x equal sized width. And the width can be found by taking the difference from the extreme points. 6 minus 1 divided by the number of segments, which is 5. 6 minus 1 is 6. 6 minus 1 divided by the number of segments. So that will give you the step size. Looking into this formula here, so right here, this is your step size, delta x. That's your step size. Okay, in this case, this one came from this step size here is different. There's only one segment here, b minus a divided by 1. Okay, but the step size here below here is different because it's b minus a divided by 5. Using this formula now, we're going to solve that problem. Using this formula, we're going to find the area under the curve. So are you all okay? Any questions? Are you all be still connected?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Area under the curve can be approximated by that formula. So the formula is delta x divided by 2. And just rewrite this formula for this problem. It's delta x divided by 2 plus fb. Just apply this formula for every segment. Okay, the first segment starts from, the first segment is here. The first segment, that's the first segment, from 1 to 2. And there's another second segment is from 2 to 3. Third segment is from 3 to 4. Fourth segment is 4 to 5. Fifth segment is from 5 to 6. since delta x over 2 is common for all, I can just keep it outside. It's okay. You might just, never mind, I will can keep it here. Delta x over 2. In this case, your delta x, let's calculate the delta x. Delta x was calculated to be 1, right? Here, delta x. Delta x is 1. But for now, just leave it as delta x. Okay, for the first segment is f1 plus f2 divided by 2. Okay, the 2. Okay, just leave the 2 here. And then next one is plus f2 plus f3 divided by 2. So you repeat this for every segment, delta x. And next you start from f3 plus f4 divided by 2 plus delta x, f4 plus f5 divided by 2. Okay, is it clear? We're just using the endpoints. For each segment, we are just using the endpoints. Like this is the one from year to year, first segment. Again, second segment, year from year to year. Third segment, from year to year. Fourth segment, from year to year. Fifth segment, from year to year. Any question?
No, sir.
Yeah? Yes? Any question?
No, sir.
Oh, okay, thank you. That's what I can do. You can do it any way you like. You know, I'm just doing this in a different way. I mean, more on the teaching mode. You can just take out this delta x over 2, which is common for all, right? And then you can just write like this, f1. And then you see right here, you have f2 here, and then you also have f2 here, correct? So then you can write this as plus 2f2. If you have a good calculator, you can, you write, the less you write, the more compact you can reduce it. The less numbers you need to punch in into your calculator. Plus 3f3 plus, sorry, 2f3 plus 2f4. The last one is plus f5. Sorry, we have f6 here. We still have f5. Do we have f6 here?
Sir, you less
You
one
left
more
one, son. F6 missing, sir.
Yeah, why didn't you tell me earlier? G.
Now I just realized something's wrong. But now I
Thank
just
you, G.
got it.
F6. I thought I want to finish earlier and had breakfast, but that's why I overlooked. I got emotional. I'm sure you guys are too, right? Want to finish early and have breakfast. 2F5 plus F6. Okay. So this F here, you know your Fx, right? Your Fx is a function that was given earlier, x minus 1, right? So if when f is 1, you just plug in 1 inside here, for f is 1. So you evaluate this formula at x equals to 1, 2, 3, 4, 5, and 6. Okay, let's do that. Delta x, we know earlier, it's 1. So delta x is 1 over 2. 2 is just a standard, is part of the formula. Delta x was calculated earlier to be 1. When you plug in 1 into this formula, the first one you will get is, what do you get? The square root of 1 minus 1 plus 2 square root of 2 minus 1 plus 2 square root of 3 minus 1 plus 2 square root of 4 minus 1 plus 2 square root of 5 minus 1 plus square root of 6 minus 1. Doing all these things by hand is of course tedious, you know. That's why computer play an important role in numerical analysis. This is going to be 1F. The first one is 0 plus 2 times square root of 1 is just 2 plus 2 square root of 2 plus 2 square root of 3 plus 2 square root of 4 is also 2, so it's just 4. And then the last one is just square root of 5. Okay, you have a punch into your calculator, the answer will just pop out. It's approximately 7.26. So this is numerical analysis. Usually you'll get a lot of decimal places. Usually people get try to be very accurate as possible, but now this is just for fun. I mean, not for fun. I mean, just simplifying things. So this is your IF, the area under the polynomial of degree 1. This area is not the actual area. It is estimating the area of fx under the curve fx. So we have something that maybe you have a solution to a differential equation. For example, you have a solution to a differential equation. Assume a solution. Actual solution And then we are given the dpq, and then we are also given an initial condition, an initial point, given IC. IC stands for initial condition, not the integrated chip. IC here stands for initial condition. Initially, you are given a point, and then you are also given the differential equation. What are the things you're given? You're given the differential equation, dy dx. So these things are given. Then you develop a computational method to try to approximate by generating points. You may not be accurate, you can get close to it, but you get something, approximate solution to the actual solution. Some differential equations are not possible to solve in traditional way. So they use this type of computational method. Points generated See, now we will see how the formula is developed. For example, here is what we have. You have a curve. You have the actual solution, actual point. This is the actual point. It's not possible to find. Not possible. Assume it's not possible to find, don't need to confuse you. This actual point, which is not possible to find, but you're trying to predict that point using the Euler's method. The way you do it is, provided you are given an initial condition, provided you are given, let's say you are given an initial condition, initial point given. And then what you do, you generate, you try to draw a tangent line. You try to, now you try to sketch a tangent line to approximate the actual point. Okay, let's say I'm drawing a tangent line here. Maybe it is no good. Let's say I'm drawing this tangent line to approximate the slope. Okay, to approximate the slope. So from this tangent line, you'll be able to, tangent line, you guys know what's a tangent line, right? Tangent line is a line that's going very close to the curve and only touching, only at one point. Just slightly touching it at the periphery. It's the boundary, at the boundary. Tangent line. So once you are given this, once you're given this point, what you do with this point is you try to generate another point. You try to generate another point here. Call this point x1. And this is y1. You generate another point by finding the slope of this tangent line. The slope of this tangent line is delta y divided by delta x. This is an approximation close to solution curve. Actually, we are not finding the slope. We are using the slope method here to find the solution of the differential equation, to approximate the solution of the differential equation. Approximation close to the solution curve. In this case, the step size from year to year is called the step size. Step size, which is delta x, the step size. So using all this, you are trying to solve a problem. To start a problem, you should be given an initial condition. To solve, you should be given an initial condition x naught to start. Okay, let's start. To develop the formula, start. For example, x naught, we're given this point. X naught, just call this x naught, and then y is y naught. I'm sorry. X is x naught, and then y is given the differential equation. Differential equation, you can call this differential equation fxy. This differential equation is just a slope on a line, and it's also called fxy. Let me rewrite this again. Fxy is defined to be the dy dx, the actual slope on the line. Slope fx naught y naught is delta y is the slope of the tangent line. From here, you can solve your delta y is going to be delta x multiplied by this is the slope of a straight line of the tangent line. A straight line. So every time when you move, you draw a new tangent line. Are you guys still around?
Yes, sir.
Yes, sir.
Okay, let's
Yes,
move on. We are close to being done. Just give me I think we'll be done pretty soon. Okay, now to be able to, using this, okay, after you draw the tangent line, the next point, we can approximate the next point by finding x1. x1 is the next point. x1 is the next point, is the initial point, given point, plus the step size. Similarly, the y1 is going to be initial point plus delta x times by the the function with the initial value plugged in. When we do the example, you'll see. So x2 similarly is going to be x1. x2 will find next point. Once x1 is found, then you can find x2 using this formula. Then you can also find y2 using this formula. Okay, this is how the formulas. If you continue to do this, you'll develop a general formula called x of n. The next point is equals to previous point plus delta x. And therefore, the y point is y of n is going to be in the previous y point plus delta x multiplied by x x n minus 1 y minus 1. Okay, this is the general formula. Now we use this formula to solve a problem, simple problem. And then after that, you can go home. You're already at home, but your mind is not at home. Example, approximate the y point given the x point 0.4 using Euler's method. You're also given, these are the things given to dy dx is x plus 2y. And you're also given the initial conditions without these things, you won't be able to use Euler's method. These things must be given. Okay. And the step size also must be given, the step size, delta x. So all these things are given to you. You know, all these things are given. Info needed to solve dy dx, initial condition, x equal to 0, and what is y. Once you plus x equal to once you plug in x equal to 0, then you know what y is, right? That also is given to you. And then on delta x also given. Info needed to solve. Next, you use this formula, bring this formula down here for reference. These things are given to you. We are using this formula, applying this formula. Also note that dy dx is x plus 2y. And it is also same as fxy. Although this is a slope, but we call this x fxy because it's going to give you a point on line. Okay, that's it. And then for okay, start. How do you start? How do you start? You start with what was given to you. Start with the initial condition that was given to you. When x naught is equal to 0, then the initial point, initial value is called x naught. Initial y value is called y naught. Initial x value is called x naught. It's given to you is 0 for x naught, and y naught is also 0. Then you find the next point. Find the next point. Next point. Find x1. x1 is what? Remember how you found x1? You found by using this formula. Applying this formula. Okay, let me write this in blue so you can see xn is equals to xn minus 1 plus delta x, correct?
So is x1 minus 1.
Xn minus 1.
Yes, sir.
Xn minus 1. Okay? Okay. Okay, this is a formula. So when n equals to 1, what is xn minus 1? G.
Yes, sir.
When n equals to 1.
Okay.
So what is xn minus 1?
So it's x1 minus 1, sir.
Okay, when n is equals to 1, okay, when I put the n here as 1, right? Then what is xn minus 1? 1 minus 1, right?
Yes, sir.
Okay. X0 plus delta X. Okay. All right.
Yes, sir.
See? So
Yes, sir.
therefore, then that's how you find the next point. X1 is equals to, what was X0? What was X0?
1.
0. It's a 0 here. It's given to you. Follow? Follow or not?
Yes, sir.
Then what is delta X? Delta X is given here, right?
0.1, sir.
Okay. Plus 0.1. Next, let's go ahead and find y, the corresponding y value using this formula. I'm just putting this here for reference. On blue or red, whichever. So how do you find using this formula when n is equals to 1? Next point, okay, I put here n equals to 1. Okay, now I leave everything in blue so that I need to go for a course to figure out how to use colors. Give me another 10 more minutes or 5 minutes, I'll finish this. Are we all okay?
Yes, sir.
Yes, sir.
Okay, now n equals to 1, therefore y1 is equals to y0 plus delta x f x naught y naught. Okay. Okay, what this is, I need to highlight this right here. Okay, this is going to be like x naught plus 2y naught. You understand or not? It's coming from here. It's coming from here. For example, fx naught okay. So our y1 is going to be, what is y naught? What was the y naught value that was given?
0.
Significant. Okay, 0. Our step size
0.1, sir.
still the same, 0.1, and then multiply by what is x naught plus 2y naught?
X naught so 0, 2y naught so 0, sir.
So all 0. So therefore x1. So therefore x1 is going to be 0.1, and then y1 is 0. So these are the next values that you need. Next point. These values are needed for you to calculate the next point. Next point, when n equals to 1. Next point. Next point is when n equals to 2. So now you go ahead and look at the blue x2. Look at the blue equation. When x2 is equals to x, 2 minus
X1.
1 is
X1.
1 plus delta x. Now what was the x1 calculated earlier? What was x1 calculated? Yeah, right here.
1.
0.1. X1 is 0.1.
0.
We calculated earlier, right? X1 is 0.1 right here. You guys are following? There's a big group of people sleeping behind.
Yes, sir.
Yes, sir.
Wait, you get the midterm, then you don't wait. 0.1 plus, what was delta X?
Same number, 0.1.
So therefore, X2 is 0.2. What is the corresponding Y2? Go to the formula. Y2 is Y1 plus delta X multiplied by F X1 Y1. Okay, remember again, I told you this part here is going to be what? I mean, X1 plus 2Y1. Keep that in mind. Therefore, Y2 is going to be, what was Y1 earlier that you calculated?
0, sir.
0. Delta X?
0.1, sir.
Okay, then X1 plus 2Y1?
X1 0.1. For Y1 0.
X1 is 0.1. Okay. And then Y1?
0, sir.
Okay, 2 times 0 is 0. Okay, so therefore, overall, Y2 is going to be 0.1 multiplied by 0.1. Right or not? 0.01. Maybe it looks messy. Yeah, I don't know. Okay, now once you're done with that, you're going to see, you are told to find, what are we told to find here? We are told to find, I forgot to tell you, find, given all these things. Okay, we are told to find this. So we need to go until 0.4, okay?
Okay,
Just one
sir.
more step, just couple more steps only. So next is n equals to 3. N equals to 3. Therefore, using the, look at the blue formula, in the formula in blue, x3 is equals to x, 3 minus 1 is 2, plus delta x. Okay, then y3 is going to be, look at that formula in blue, y2 plus delta x f x2 y2. Okay, what was x2 that you calculated earlier? X2,
0.2, sir.
okay, 0.2. Delta x?
0.1,
1.
sir.
Delta x 0.1. Delta x is always 0.1, is standard, right? That it was given to you. Because somebody was saying 1, I don't know. Because delta x is always same, it's already given to you. It's okay, you guys make mistake now. You don't want to make mistake during the exam. So it's okay, you guess something. So nothing wrong in that. So y3, what was y2? Y2 that you calculated earlier from here?
0.01, sir.
0.01.
0.01 plus 0.1. And then 0.01 plus fx2, then you're going to have here x2 plus 2y2, right?
Yes,
x2, what was x2?
sir.
0.2, sir.
0 plus 0.1. X2 was 0.2. Y2,
0.01, sir.
0.01.
so times by 2 becomes 0.02. Okay, then Y3 will becomes how much? 0. Okay, now let's calculate this. So Y3 is going to be 0.01 plus 0.1. What's inside the parentheses is 0.22. 0.22 or 0.22.
Yes, 0.22, sir.
How much is that? Y3 then?
Zero point 0.42.
0.42.
Total 0.042. Total
0.0.
42.
Some parrot screaming behind.
Oh, it's my pet Chaco screaming.
Chaco.
My parrot name Chaco.
Okay, good. Parrot is learning something. How much is that again? Guys, please calculate this.
0.032, sir.
Okay, 0.032. Answer. So the last one, that's it. When n equals to 4, the next one, x4 is going to be x3 plus delta x. x3 was calculated as how much? 0.3. 0.3 plus 0.1. x4 is 0.4. Okay. Then therefore the corresponding y4 is going to be the formula is y3 plus delta x plus f x3 y3. Okay, then y4. These things keep coming out. Okay, y3 we calculated earlier was 0.032 plus delta x 0.1 multiplied by 2. What was that equation again? Sorry, x3 plus x3. Why these things are doing this? X3 plus 2y3. So that's going to be 0.032 plus 0.1. X3, what was X3? 0.3.
0.3, sir.
0.3 plus 2y3. 2 times y3 is how much? 2 2 times y3, which is 0.032. 0.032 plus 0.1. Okay, how much is this? 0.032 times by 2 is 0.064 plus 0.3 is 0.364. Is it?
0.664.
64. 0.664.
Ah, yes, sir.
Okay,
364, sir. 364.
364. 0.1 times 0.364. Finally, going to give you how much?
0.0684, sir.
0.0664.
684.
Okay. So that's the answer, you know, when x4 is 4, 0.4, y 0.4, so this is what the problem asks us to solve, right? Okay, guys, thank you very much. Okay, we are done here. Just to summarize what we have done here. Let's summarize what we have done here. Let's say we have a solution like this, the actual solution. Actual solution to actual solution hidden. We don't know what the solution is. So now we are using the numerical method. Given an initial condition, given this initial condition, we are using this initial condition to find we are calculating all these corresponding 0.3, so for each of these x values, given the initial condition, then we calculated the subsequent x1 and y1 values to approximate the solution to the actual curve. Something like this. That's what we are doing. Okay. Any question?